Hello, Honors Algebra. Mr. Lawrence here. I am pleased to say, one, that I got a good report from the sub. I'll be grading your test this week. And just what I want to do on my birthday. Thanks a lot, you guys. Oh, wait, I'm the one who scheduled the test for today. My mistake. Ha! All right, this is going to be an easy lesson, guys. It's almost intuitive. We're going to be learning to work with monomials. Monomials. It looks like mono meal, but it's not spelled right. It's monomials. And all a monomial is, mono means one. This means one. So we're going to be learning to be multiplying monomials together. One term. All right. Now, before we do that, I want you to think, is there a shortcut way of saying 3 times 3 without giving the product? Hopefully, Jewel is yelling out, yeah, 3 to the second power, right? Because 3 to the first, 3 to the first, 3 to the second. Is there a shortcut way to say 7 times 7 times 7 without saying the product? Well, I know Quinn knows that this is 7 to the first, that's 7 to the first, that's 7 to the first, 7 to the third. Now, I know Matt Bliznick is so sharp, he pricks his finger every time he scratches his head. But that's beside the point. He just noticed that, hey, when the bases are the same, when the bases are the same, when the bases are the same. Oh, I know somebody just got lost. They're like, what's a base? Guys, remember, this is the base. That's the base, right? And then this guy up here, he's the exponent. Exponent. Yes, I like to say exponent. All right, when the bases are the same in multiplication, this is only for multiplication, I add the exponents. I add the exponents. So, for example, 1 plus 1 plus 1 is 3. So 7 times 7 to the first times 7 to the first times 7 to the first. The bases are all 7. The exponents are all 1. 1 plus 1 plus 1 is 3. Well, that being said, I know James Bollinger is thinking that 5 to the third power times 5 to the fourth power must be 5 to the seventh power. Now, I know somebody out there is going, wait a minute, how'd you do that so fast? Well, I did 3 plus 4. But let's think about it. What does 5 to the third power mean? It means 5 times 5 times 5, right? And 5 to the fourth is 5 times 5 times 5 times 5. And of course, we have to multiply them together. What's the shortcut way of saying 5 times 5 times 5 times 5 times 5 times 5 times 5? 5 to the seventh power. There you go. You see how simple that is? Real simple. Don't make it difficult, guys. Don't make it difficult. So, how would you do a problem like this? Say x to the third times x to the seventh. Well, ask yourself, are you multiplying? Yes, I am multiplying. Spencer Brody, what's the base? Did you hear him? He shouted out x. The base is x, because the exponent on the first one is 3. The exponent on the second term, monomial, is 7. The base is x. The bases are the same. All Spencer has to do, he knows, is to add the exponents and get x to the 10th power. If you don't believe me, just think, what does x to the third mean? X times x times x. X to the seventh means x times x times x times x. Oh man, I lost track of x's. There's 3, another x, a 5th x, a 6x, a 7th x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The shortcut way would be x to the 10th, right? Okay, now this is super duper simple. How would you handle a problem like this? I hate to tell you this, guys. I'm going to keep this video under 15 minutes. I think you guys should like bring me in roses or something on Monday morning. All right, don't do that for real, please. Unless they're chocolate. I love chocolate roses. Nice little sidebar. 3 times x to the 6th times 2x to the 8th. Okay. Well, I know you all know how to multiply. I know you all know how to multiply 3 times 2. At least you better, or Mr. Lawrence is going to freak out on you. 3 times 2 is 6. Now I'm going to look at the x's. They have the same base, yes? I have an x to the 6th power and an x to the 8th power. that must mean I have x to the 14th power, because there are 6 x's here being multiplied, and there are 8 x's here being multiplied. So altogether, 14 x's are being multiplied. Instead of saying, Mr. Lawrence, the answer is, and I know that Matt Russ would probably like to do this just to give me a hard time, he would say 6 times x 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 times x. And there were 14 there in case you were watching. I was counting on my fingers and toes. Ooh, gross. Okay, so 6x to the 14th power. Well, if you can do that and you think that was simple, try this one. How about negative 4x to the 5th y times 7x squared y to the 8th. Take it in parts. The first thing I'm going to do is I'm going to multiply my coefficients. You should be familiar with that term. I've been using it an awful lot lately. Coefficients. I'm going to multiply those. Negative 4 times 7, negative 28. There we go. Next, I'm going to multiply my x terms because they have the same base. X to the 5th times x squared is the same as, go on, say it. Come on, Myriad, I know you know it. X to the 7th power. There we go. All right, and then I will multiply my y's. Why? Because it's in the problem. There's a y. There's a y to the 8th. Remember, the exponent on this y is a 1. Some of you may want to write that in for a little security blanket. I know that Sean Kilbane doesn't need it, but somebody else might want to write it in. Let's see here. We need y to the 1st times y to the 8th. That'll be y to the 9th. Okay. Now, for the record, you could have written negative 28 y to the 9th, x to the 7th, but as a rule, we tend to do it alphabetically. That way, everybody's doing the same way. If you should forget to do it alphabetically on a test and do that, you will get full credit with a note from me, please write them alphabetically. Okay, that way everybody's doing the same. Now, let me ask you this. How would you do x to the 5th times y to the 7th? I know some of you are thinking xy to the 12th, and no, it is not. Who can tell me why it won't be xy to the 12th? Oh, you can't tell me, Mr. Lawrence. I can't hear you. Oh, but I'll bet you Nathan Sperber is going, Mr. Lawrence, the bases aren't the same. So x to the 5th, y to the 7th must simply equal x to the 5th, y to the 7th. And he's absolutely correct. All right. All right. I'm going to give you 3 problems to do. You do them, knock them out, and then you'll be good. Actually, I changed my mind. I'm only going to give you 2 problems. There they are right there. Go ahead and pause the video. See if you can do them on your own. These are harder than the examples I did, but if you can handle these, Monday's homework is going to be so simple. Go ahead and pause the video, get your solution. Before you do that, I would just want to remind you your projects are due Wednesday, right? Monopoly board projects. And if you needed a rubric or something, hopefully you got it from the sub. If you didn't, come get one Monday. Okay, Andrew, if you're listening to this, I know you've been out and I created a rubric after you left. If you need extra time, don't rush to get it done. Come talk to me when you come back, I think on Tuesday, and we'll talk and give you a couple extra days, okay? It's not your fault. If you have it done already, I'm not going to make you redo it. You and I will talk, and I will give you like an adjusted rubric. Okay, because you didn't know all the expectations before you left. All right, good deal. Go ahead and pause, and in a moment, my answers will show up. Okay, if you've unpaused, you're ready to see my answers. I know that 6 times 5 times 2 is 30. No, it is not. It's 60. Okay, and I know that x to the 5th times x to the 1st is x to the 6th. And then I got a y to the 1st, a y to the 7th, and a y to the 1st, which would be y to the 8th. All right, there we go. Pretty simple. All right, the second one, I know, you know what, I'm not going to go negative 3 times 4 times 3. I'm going to do negative 3. I'm not even going to worry about the negative at the moment. I'm going to do 3 times 3 is 9, and times 4 is 36. And I said the word negative 1 time. I see see 1 negative in the whole problem, which means that the problem will be negative. Excuse me, the product will be negative. All right? Okay, let's see, I got an x to the 5th, an x negative 1st. Well, if I add those together, I get 1 plus 5 minus 1. Well, 1 and minus 1 turn to 0, so that's an x to the 5th. All right, I got a y to the 10th, a y to the negative 2nd. I'm down to y to the 8th. I got a y to the 1st. I'm back up to y to the 9th. And you guys can do this quickly. It's super duper simple. I got a z times z times z. Now, before you think the answer is z, stop and think. Is 2 times 2 times 2 2? It's 5 times 5 times 5, 5. Now I saw some little smarty pants is going, yeah, Mr. Lawrence, but 0 times 0 times 0 is 0, and 1 times 1 times 1 is 1. But we know that 2 times 2 times 2 does not equal 2. So if you're trying to use that rule, I've just proven you wrong by providing a counterexample. All right, Mr. Lawrence is going to sign off here. I hope you have a great weekend, and I'll see you guys on Monday.